question 1, we are given a frequency polygon, but it's not fully correct, and we need to identify two things that are wrong with this frequency polygon. Well, obviously the first one to note is that this straight line here joining these 2 points should not have been drawn. So we simply say that the points 15, 8 and 55, 3 should not be joined together. A second thing that we can note is that the point here has been drawn wrongly. It should have been 15,6 and it's actually at 15,8. So we could say that the first point should be 15,6, not 15,8. And actually there's a third point we could raise, and that is that the vertical axis has not been labeled. So we can also mention this. In 2, we've got a length of 120 millimeters correct to the nearest millimeter, and we need to complete the error interval. So we know that we go 128 plus minus 0.5. So the length of this error interval is exactly 1 millimeter plus a half up to minus a half, and therefore it goes from 127.5 up to 128.5. In 3, we've got Tom and Adam having a total of 240 stamps. They have the stamps in the ratio of 3:7, and then Tom buys some stamps from Adam so that they are now in the ratio of 3:5. We need to find how many stamps were bought from Adam. We start by drawing up a table. So we've got Tom, Adam, and the total. We knew that originally they were split in the ratio of 3:7. Now 3 plus 7 is 10, and actually there's a total of 240 stamps. So we can see that to go from 10 to 240, we multiply by 24. So 3 times 24 is 72, and 7 times 24 is equal to 168. This gives us the original number of stamps that each person had. And now they are split in the ratio of 3:5. So 3 plus 5 is 8. The total is still 240. And we see that to go from 8 to 240, we multiply by 30. So 3 times 30 is equal to 90. 5 times 30 is 150. We can see that Tom went from 72 to 90 stamps. So 90 minus 72 is equal to 18 stamps, and that's the answer to this question. In 4, we've got a sample of 50 people in the fitness club. These are the gifts they would like to have, and given that we've got 700 people in total in this fitness club, we need to work out how many sports bags we need to order. So the proportion of sports bags within the sample is 17 out of 50. So 17 out of 50 times the total of 700 gives an answer of 238 sports bags. In II, we are asked to write down an assumption we made and explain how this might affect our answer. Well, obviously we assume that the sample is representative of the population, and therefore we can generalize what we've seen in the sample to the population. And if this was not the case, then Stan may need more or less than the 238 bucks. In question 5, we've got 6 different graphs, and we need to identify which one matches to y's x cubed. Now, first of all, we can see that it's only B and F that are cubic graphs. However, B has 3 distinct cuts on the x-axis. X cubed has only 1 cut on the x-axis, so y's x cubed has to be F. In B, we've got y is 1 over x. It's a reciprocal graph. The 2 reciprocal graphs given are C and D, and we know that since we've got y is 1 over x, then the graph will be in the first and third quadrants, so it's gonna be D. In question 6, we've got 2 different sequences, 2n squared minus 1 and 40 minus n squared, and we need to show that there's only one number that is in both of these sequences. Now, to do that, we start by drawing up a table for different values of n and the 2 sequences. So when n is 1, 2 times 1 squared minus 1 is equal to 1, and 40 minus 1 squared is 39. When n is 2 times 2 squared minus 1, which is 7, and 40 minus 2 squared, which is equal to 36. And I need to keep working through different values of n until I figure out what's happening. 2 times 3 squared minus 1 is 17, and 40 minus 3 squared is 31. When n is 4, is 2 times 4 squared minus 1, which is 31, and 40 minus 4 squared is 24. So we can see that we have already found a term that is common to both sequences, but we still need to work through more values of n. 2 times 5 squared minus 1 is 49, and 40 minus 5 squared is 15, and then 2 times 6 squared minus 1 is 71, and 40 minus 6 squared is 4. Now notice that the first sequence is ascending, the second sequence is descending, and therefore they could only meet at one place, and all other values of n do not yield a common term, and therefore what we can say is that since one is an increasing sequence and the other is a decreasing sequence, only 31 in both sequences. In 7, we need to work out 3.42 times 10 to the negative 7 divided by 7.5 times 10 to the negative 6. We plug this on the calculator, we get 0.0456, which is 4.56 times 10 to the negative 2, because we were asked to give our answer in standard form. In 8, we've got a relationship for the number of days taken to build a house, and we've got n people working each day. Now, Ali took 40 days to build the house, and Haley took 30 days. We need to work out how many more workers Haley required compared to Ali. So, for Ali, we know that D is 40, it's the number of days. So 40 is 720 over n, and therefore 40n is 720, which means that n is 18. Whereas for Haley, we know that the D is 30, so 30 is 720 over n, and therefore 30n is 720, which leads to n being 24. So 24 minus 18, we need an extra 6 workers for Haley. Question 9, we've got a cube and a cuboid. We are told that the total surface area of the cube is equal to the total surface area of the cuboid. And Janet says that the volume of the cube is equal to the volume of the cuboid. We need to check whether Janet is correct. So we start by calling each side of the cube x. And therefore we know that the total surface area of the cube is 6 times x squared, because we've got 6 identical faces, each having an area of x squared. And then for the cuboid, we've got the face of 6 times 8 appearing twice, the face of 6 times 18 appearing twice, and finally the base, which is 8 times 18, which also appears twice. So the total surface area of the cuboid will be 2 times 6 times 8 plus 8 times 18 plus 6 times 18. So we end up with 6x squared being 600. So x squared is 100, which means that x is the square root of 100, which is 10. We now have the dimensions of the cube. So the volume of the cube will be simply 10 cubed. So it's going to be 1,000 cubic centimeters, whereas for the cuboid, the volume of the cuboid is given by 6 times 8 times 18, which gives an answer of 864 cubic centimeter, and therefore we see that 864 is not equal to 1,000, and therefore Janet is wrong. In 10, we need to make k the subject of the given formula, so we need to isolate k. We start by squaring both sides. This leads to y squared is 2m minus k, and therefore k is 2m minus y squared. That's the final answer. In 11, we've got Megan growing potatoes. We've got the box plot here showing the weights of Megan's potatoes. And Megan says that half of her potatoes weigh less than 50 grams each. And the question is whether Megan is correct, and we need to give a reason for our answer. Well, actually looking at the box plot, we see that the median is 57, and therefore Megan is wrong because the median is 57, hence half of the potatoes weigh less than 57 grams each. Now Amy also grows potatoes, and we've got the box plot here showing the weights of Amy's potatoes, and we need to compare the distribution of the weights of Megan's potatoes against those of Amy. Well, we can look at the interquartile range and the medians. So the median for Amy, we can read it off from the box plot, it's 42, and the interquartile range is simply the width of the box here. So it's 51 minus 35, which is 16. And we will do the same calculation for Amy. So going back to Amy, we have already established that the median is 57, and the interquartile range, again, it's the width of the box plot, so it's 65 minus 39, which gives an answer of 26. So we know that the median for Megan is greater than Amy, and the interquartile range for Megan is greater than the interquartile range for Amy. So one thing we could say is that Megan's potatoes have a higher median than Amy's because 57 is greater than 42, and also that the weights of Megan's potatoes are more spread out as they have a higher interquartile range. 26 is greater than 16. In 12, we are asked to work out the size of the angle EAD, which is in this triangle. However, I will start by focusing on triangle BCD, shown highlighted here, to find first of all the length of BD. So we've got that sine of 40 is equal to BD over 8.6, and therefore 8.6 sine of 40 is equal to BD. Now we've been told that E is the midpoint of BD, and therefore BE and ED are equal in length. So we can simply say that DE is a half times 8.6 sine of 40, and this gives an answer of 2.76398 . And therefore now in the triangle EAD, we know ED, we know AD, we are looking for the angle EAD. So this is simply calling for tan. So tan of EAD is 2.76398 over 4.4. So to find the angle EAD, we need to do shift tan of the right hand side, 2.76398 over 4.4, and this gives an answer of 32.1 degrees. In 13, we're told that Sakira invested $3,550 in a savings account for 3 years. She was attracting compound interest of 2.6% per annum for the first 2 years, and then R% of interest for the third year. She ended up with an amount of £3,819.21 at the end of the 3 years, and we need to work out the value of R. It makes sense to draw a diagram here. We've got the original, we've got 3 years, and then we've got the new. Now, the 2.6% per annum is equivalent to a multiplying factor of 1.026, and this was happening for 2 years. And I will call the multiplying factor associated with the interest of the third year M to make my life a bit simpler. We started off with 3,550. We ended up with 3,819.21, and therefore 3550 times 1.026 squared times M is 3819.21, which means we can find M by dividing 3,819.21 by 3,550 times 1.026 squared. This turns out to give an answer of 1.021998, and therefore a multiplying factor of 1.021998 is equivalent to a percentage increase of 2.2%, and therefore the value over to one decimal place is 2.2. In 14, we've got Sadia, who's buying a new car. She can choose body color, roof color, and wheel type. She's got 19 options of different body colors, 25 different wheel types, and she ends up with a total of 3,325 different ways. We need to work out the number of different roof colors, so it makes sense to write down the different options. So for body color, it's 19 different options. For wheel type is 25, and for roof color is X. So therefore 19 times 25 times X is the total of 3325, which means that X is found by dividing 3,325 by 19 times 25, which gives an answer of 7. In 15, we need to expand and simplify the triple set of brackets. I will start by expanding the first set of brackets. It's going to be 6x squared plus 3x plus 4x plus 2, close brackets, and then x minus 5. I will collect the like terms in the first bracket, so 6x squared plus 7x plus 2, close brackets, x minus 5, and then a further expansion to give me 6x cubed minus 30x squared plus 7x squared minus 35x plus 2x minus 10, and the last thing to be done is to collect like them together. So we've got 6x cubed minus 23x squared minus 33x minus 10. In question 16, we've got 9 cards numbered from 1 to 9. We've got Marek, who will be taking at random 2 of the cards, and he needs to work out the product of the numbers on the cards. What's the product? The product is an even number. What we care about here is whether the number drawn is even or odd. We are not really interested in the actual number drawn. So we can draw up a tree diagram here, which looks something like this. So the first row will be either an even or an odd number, and we've got 4 out of 9 being even and 5 out of 9 of being odd. And then if we draw the first time an even number, then we're left with 3 even numbers out of a total of 8. And 5 over 8 is the odd. And if the first one was odd, then we've got 4 out of 8 for even and 4 out of 8 for odd. We want to end up with an even product, so it's going to be even times even times odd, or odd times even. So the probability required would be 4 over 9 times 3 over 8 plus 4 over 9 times 5 over 8 plus 5 over 9 times 4 over 8. This gives an answer of 13 out of 18. In 17, we need to work out the size of angle CAB. So I'm starting off by identifying that OAD is a right angle because it's an angle between a tangent and the radius at the point of contact. And then the angle at B is theta, and the angle at A is also theta because triangle OAB is isosceles. So let's state this down. OAD is 90 degrees. Then theta plus 90 plus 32 is equal to 180. I'm adding up the angles in triangle BAD shown shaded here. So 2 theta plus 122 is equal to 180, which means that 2 theta is 58 and theta turns out to be 29 degrees. Now CAB, I'm just going to do 180 minus the theta and the 90. So CAB is 180 minus the 29 plus 90, and this works out to be 61 degrees. In 18, we've got a histogram showing information about the heights in meters of the trees in a park. It's an incomplete histogram. In addition, we are told that 20% of the trees have a height of between 10 and 12.5, so that's the 12.5 mark. and we need to complete the histogram. We know that in a histogram, the main idea is that the area is proportional to the frequency. So we will start by calculating the area of each bar. So the first one goes from 0 to 2.5 and has a height of 1.2. So 2.5 times 1.2 is equal to 3. The second one goes from 2.5 to 5. So it's going to be 2.5 times a height of 2, which is 5. Then it's 5 times 2.8, which works out to be 14. And then from 12.5 up to 25, it's 12.5 times a height of 0.8, which is equal to 10. Now I will add this up. So 3 plus 5 plus 14 plus 10 is equal to 32. And I'm going to use a ratio here. I'm going to say that 32 squared units represent 80% of the data because 20% is in the missing class here. So how many squared units to represent 20%? So x is 32 times 20 over 80, which works out to be 8. So what we are missing here between 10 and 12.5 is a rectangle that has obviously a width of 2.5 and an area of 8. So we can simply consider this situation here. It's easy to see that the height can be found by doing 8 over 2.5, the area divided by the width, which turns out to be 3.2. So coming back to the histogram, we can easily add a bar that goes up to a height of 3.2. In 19, we've got a hemisphere with a diameter of 8.4, and we need to work out its volume. We start by saying that the radius of this hemisphere is 8.4 divided by 2, which works out to be 4.2. I'm using the formula provided for the volume here. So the volume will be a half times 4 over 3 pi r cubed. So it's a half because it's a hemisphere, it's half a sphere. This works out to be 155 cubic centimeters. In 20, we are told this formula here, d is an eighth of c cubed, and c has been given as 10.9 to 3 significant figures. By considering bounds, we need to work out the value of d to a suitable degree of accuracy. So I start by considering c was 10.9 to 3 significant figures. So it could be anything from 10.95 up to 10.85. So I could find the upper bound for d, which will be 1 over 8 times 10.95 to the power of 3. This works out to be 164.1165 ... And the lower bound for d will be found by using the lower bound for c. So 1 over 8 times 10.85 cubed, which is 159.6611 ... Now looking at the upper and the lower bound, we know for sure that the true value of d is somewhere between 159.66 and 164.11, and we see that the upper and the lower bound agree to 160, correct to 2 significant figures, and therefore we simply say that since the upper and lower bounds agree to 2SF, d is 160 to 2 significant figures. In 21, we've got a speed time graph for a train journey, and we know that it took 100 seconds in total. We need to calculate the time taken by the train to travel half the distance. Well, we will start by finding the total distance covered, and this is found by calculating the area under a speed time graph. So we've got a trapezium essentially. This here is 30, and it's at a height of 12. And then we've got here the 80 coming down. We know that the formula for the area of a trapezium is base 1 plus base 2 over 2 times height. So the total distance covered in this case will be 50 plus 100 over 2 times 12, which gives an answer of 900 meters. So we need to find the time taken to cover half of this distance, which is 450 meters. I will start by considering the area for this triangle here. So by finding the area of this triangle, we are finding the distance covered in the first 30 seconds of the journey. So the distance here is 30 times 12 over 2, base times height over 2, which is 180 meters. So 450 minus 180 is 270 meters. So we need to find the time to cover those 270 meters. Now, during that time, the speed was traveling at a constant speed of 12 meters per second. It had to cover a distance of 270 meters. So 270 divided by 12 gives an answer of 22.5, which means that 22.5 seconds after the 30-second mark, we have reached half the distance between the two stations. So 30 plus 22.5 gives an answer of 52.5 seconds. In B, we need to compare the acceleration during the first part of the journey against the acceleration during the last part of the journey. So going back to the speed time graph, we can make two observations. The first one is that the train was accelerating at the beginning and decelerating at the end of the journey. So it was picking up speed as it started off from rest, and then it was decelerating, it was coming to rest, so the speed was decreasing. Another thing we could say is compare the gradients. We can see that while decelerating, this is steeper than this part here, and therefore we can simply say that gradient is steeper during the last part of the journey, hence acceleration is greater, and also positive acceleration at the beginning, negative at the end. Any one of these 2 points will give you the mark. In 22, we've got a formula for the number of rabbits the next month based on the population for the previous month. We know that at the end of March, we had 200 rabbits on the farm, and we need to work out how many of them will be at the end of June. I will actually start by drawing up a table. So end of March, we had 200 rabbits. End of April, it's 1.2 times 200 minus 50, which works out to be 190. Then for May, it's 1.2 times 190 minus 50, which is 178. And then for June, it's 1.2 times 178 minus 50, which gives an answer of 163.6. And therefore we conclude that at the end of June we'll be having 164 rabbits. In B, we need to consider our resulting part A, suggesting what will happen to the number of rabbits after a long time. Well, we see that the consecutive populations keep decreasing, so it's easy to conclude that eventually the rabbits will go extinct. In 23, we are told that the area of the parallelogram is greater than 15 square centimeters, and we need to show that this inequality holds true. I will actually start by splitting the parallelogram into 2 identical triangles, and therefore 2 times the area of this triangle should be greater than 15. So 2 times a half, AB sine C, with one side being 2x minus 1, the other side being 10 minus x. Sine of 150 is greater than 15. Now the 2 with the half cancel out. I expand the brackets to get 20x minus 2x squared minus 10 plus x. Sine of 150 is a half. This is greater than 15. I will cross multiply the 2 with the 15 to give me a 30 on the right hand side. And on the left hand side, I'm left with 21x minus 2x squared minus 10. And therefore 0 is greater than 2x squared minus 21x plus 40 as required. In B, we are asked to find the range of possible values of x, and I will start by finding the critical values by solving 2x squared minus 21x plus 40 is equal to 0. this factorizes into 2x minus 5, x minus 8, and therefore either 2x minus 5 is 0 or x minus 8 is 0. So we have that the critical values are 5 over 2 and x is 8. Now, since this is a quadratic inequality, we proceed by drawing a parabola with the critical values as shown here. So critical values at 5 over 2 and 8, it goes plus, minus, plus. We want to be less than 0, so we want to be in the middle. So at the moment, we need to be between 5 over 2 and 8, but we also need to consider that 2x minus 1 and 10 minus x are lengths, so 2x minus 1 should be greater than 0 and 10 minus x should be greater than 0. So 2x is greater than 1, which means that x is greater than a half and 10 is greater than x. So all in all, we've got 3 conditions. First one is that we are between 5 over 2 and 8. Second one, that we are greater than a half. And third one, that we are less than 10. I can put everything on a number line to see exactly what's happening. So there we are greater than a half, we are less than 10, we are in between 5 over 2 and 8. Now all of these need to be satisfied, and obviously they are satisfied between 5 over 2 and 8, and therefore the final answer will be that 5 over 2 less than x less than 8. In 24, we've got the square ABCD shown here, and we are told that we start with a reflection in the line x is -1, followed by a rotation, and under this combined transformation, we've got 2 vertices of the square remaining invariant, so they remain at the same place, and we need to describe fully one possible rotation. Now, from the instructions, describe fully one possible rotation. This implies that there are more than one possible correct answers. So we start by drawing the mirror line. X is -1, and if we reflect along this line, we see that A, B, C, D gets mapped there. So the reflection line X is -1, A dash is the image of point A, and so on. And we now need to consider possible rotations so that 2 vertices of A, B, C, D will remain invariant. So this requires some trial and error. And after some tries, we end up at the possible center of rotation being -1, 0. I can start connecting the corresponding vertices, so it will look something like this. So D dash will get mapped to D through a 90-degree clockwise rotation. Then A dash will get mapped to C through a 90-degree clockwise rotation, and proceeding like this, we see that B dash will end up at B, D dash will end up at D. So we've got 2 points that remain invariant under this rotation, and therefore we are looking at a rotation through 90 degrees clockwise about the point -1, 0. Now there are other possibilities here. One of them is a 90-degree anti-clockwise rotation about -1, 6, or 180 degrees rotation about -1, 2, and finally 180 degrees rotation through -1, 4. In 25, we've got the straight line L with equation 3x plus 2y is 17. We've got the straight line M perpendicular to L passing through point A with coordinates 0, 2. And we've got that L crosses the y-axis at B, L and M intersect at the point C. We need to work out the area of the triangle ABC. There's quite a lot of work to be done here. So let's start with the straight line L. Having equation 3x plus 2y is 17. I will start by putting this in the form y cos mx plus c. So 2y is -3x plus 17. Dividing throughout by 2 gives me that y is -3 over 2x plus 17 over 2. This means that the gradient of L is -3 over 2. And this will allow me to find the gradient of line M. So for M is perpendicular to L, and therefore the gradient of line M will be 2 over 3. We flip and we change the sign. Now point A has coordinates 0, 2, so it's actually the y-intercept of these lines, so C is 2, and therefore the straight line M has equation y is 2 over 3x plus 2. I will now proceed in finding point B. So at B, we have that x is 0. It's the cut on the y-axis for line L. So we have that 2y is equal to 17. So y is 17 over 2. And therefore, point B has coordinates 0, 17 over 2. Now, we also need to find point C, which is the point of intersection of the two lines. So at C, we've got that minus 3 over 2x plus 17 over 2. That's the y expression for line L is equal to 2 over 3x plus 2. So I'm equating the two lines because it's the point of intersection. Now notice that the LCM of this equation here is 6, and therefore this will be multiplied by 3, this by 3, this by 2, and this by 6, leading to negative 9x plus 51 is 4x plus 12. So 51 minus 12 is 39, 4x plus 9x is 13x. So we've got that 3 is equal to x. We can proceed in finding y. Y is 2 over 3 times 3 plus 2, which is 4, and therefore we have also obtained the coordinates of point C to be 3, 4. Now we have the points A, B, and C. It makes perfect sense to put this on a sketch just to have a visual understanding of what's happening. So there it is. We've got point B at 17 over 2 on the y-axis, point A at 0, 2, point C at 3, 4. We're trying to find the area of this triangle. Let me start with the base, which is simply the distance between A and B. So we will be doing 17 over 2 minus 2, which gives an answer of 13 over 2. And now for the height, it's simply the x-coordinate of point C, so it's 3. And therefore the area is given by base, 13 over 2, times height, which is 3 over 2, which gives an answer of 39 over 4 square units.